Everyday medical data is unstructured and complex. Vast knowledge from general-purpose LLMs alone cannot meet the nuanced context and safety standards required in real clinical environments. To address this, we designed Mocha, a proprietary medical LLM built for trusted use in real-world clinical settings. Mocha is not just a single response model. It is a multi-agent system where specialized AI agents for context analysis, reasoning, and safety verification operate together within a unified structure. As each agent performs its role, Mocha orchestrates the entire process, aligning them toward a single goal. Through this architecture, medical AI reasoning becomes a controllable and verifiable process. So, how can we evaluate whether a medical AI is truly safe and trustworthy? First, we quantified the quality of the medical inquiry. EPAG framework goes beyond conversational fluency to evaluate the quality of AI-driven medical interviews. It directly compares the collected history of present illness with global clinical guidelines and assesses whether critical information required for disease estimation has been captured. Through this, Mocha asks clinically meaningful and high-quality questions. Second, we evaluate disease estimates more precisely. In medicine, the value of a judgment isn't strictly binary right or wrong. Based on the hierarchical structure of ICD-10 defined by the WHO, HDDX evaluates how medically close the AI's estimation is to the correct diagnosis. This helps ensure that disease estimates are reliable enough to serve as a reference in clinical decision-making. Third, it provides clinically relevant, consistent, and non-redundant questions, even in long and complex consultations. In general-purpose LLMs, as consultations grow longer, clinical relevance diminishes, often missing key details. We define this phenomenon as format inertia and addressed it through training data distribution recalibration in Mocha. As a result, even as pre-consultations become complex and extended, Mocha maintains clinical context and ensures a continuous flow of clinically meaningful questions. And finally, the most critical priority, safety. Mocha uses a classification framework called TACOS to precisely categorize user intent into 21 distinct types. By clearly distinguishing between clinical and non-clinical questions, and between information requests and harmful intents, it proactively blocks risks while safely accessing necessary information through external tools. Mocha responds only in safe, predefined ways according to these strict standards. Medical AI must be different from general-purpose LLMs, selecting the right questions, maintaining context even in long conversations, and reasoning beyond simple answers to understand relationships between diseases. The future of healthcare infrastructure, where all these technologies are orchestrated to work as one. Mocha, AI Tricks.